Okay, so up until this point, we've integrated things that work out very nicely. And so this is going to start getting into more complicated things to integrate. So this talks about composite functions. And composite function is like a function in a function, right? The f of g, g of f stuff. And so it says, for each of the functions given below, let's find both f prime and then the integral of f prime so that you can maybe see a pattern here, okay? So if this is f of x, anytime you have a composite function, like a function in a function, remember you're going to take the derivative by using the chain rule. So if I take the derivative of this, I take the derivative of the outside. So the derivative of sine is cosine. Leave the inside alone. So cosine of 3x times the derivative of the inside, which would be 3. And now think about if I took the integral of that now. If I took the integral of 3 cosine of 3x, using what I know about derivatives and integrals, if I want to go backwards, I should get back the original function, right? Because I have to have that 3 there to take care of that 3x on the inside, right? So think about this one. If I take the derivative of e to the cosine of x, remember the derivative of e to the u is e to the u times u prime. So the derivative of e to the cosine of x is e to the cosine of x times the derivative of cosine, which is negative sine. Well, that's really gross. Okay. So I'm going to say negative sine of x times e to the cosine of x. And just now think about what that would look like as an integral. I would want to take the integral of negative sine of x e to the cosine of x. And again, based on what I know, if I want to undo this, the antiderivative would give me back the original. But I have to have this part here in order to get that original, which would just be, I guess I should have a plus c here, right? E to the cosine of x plus c. So we're kind of looking for a pattern here. And it's just kind of nice to review these. What about ln? Well, remember the derivative of ln of u is u prime over u. So my derivative here would be u prime would be 2x over x squared plus 3. So then think about if you had this antiderivative or this integral of 2x over x squared plus 3. Again, it's not really the power rule. You have to just look at it and see the pattern of that it's going to go all the way back, and you're going to get the ln of x squared plus 3 plus c. Okay, so to save time here, I'm going to skip the last one, but you could totally do the last one too. But I hope you kind of see what's happening here, that if you look for this pattern of the chain rule, you have to think about what the chain rule says. So when we have the derivative of f of g of x, remember the chain rule says we take the derivative of the outside, leave the inside alone, times the derivative of the inside, right? And remember when we first learned the chain rule, I brought in the M&Ms to think about the layers. And so you leave the inside alone, then you take the derivative of this. And so when you go backwards, if you have the integral of this, you're just going to get back f of g of x, because this part isn't in that original problem, right? Plus c. And so we call this is really cheesy, but your license to integrate. If that's missing, you can't integrate this problem. It doesn't fit that pattern, and we're going to have to talk about, well, how can I make it fit if it doesn't fit? But for now, it's going to work out nicely. Okay? Okay, so let's look at some. So now it says find each of the following indefinite integrals by pattern recognition, which means today it should kind of work. And so you have to kind of think about what's the outside function, what's the inside function. And so again, looking at this, cosine of 3x, that I could take the antiderivative of. That 3 out there, that's your license to integrate, because that would be the derivative of the inside. So when I go backwards, my antiderivative would be negative sine of 3x plus c. And again, you could always check these. Take the derivative of this and see if you get this. The derivative of negative sine, no, that's not negative, would it be? That's, sorry, I did derivative. The derivative of sine would be cosine of 3x times 3, and so that works. So what about this one? We could rewrite this as 2x times x squared plus 5 to the 1/3. Again, if you think about inside outside, this is like your inside function that you're going to need in your original function, but the derivative of this is 2x. So this is your license to integrate, right? This is needed, but when I do my antiderivative, it's not needed. And so the next video, I'm going to show you another way to do this besides just pattern recognition, but this is one way to kind of look and see, like, does it fit? And so on this one, since it does fit, I'm just going to do the antiderivative of this, right? This is my power rule, and so my antiderivative of that would be x squared plus 5, add 1 to that, so that's 4/3 divided by 4/3 is the same as 3/4 plus c. And again, you can check this over here to the side. If you did the derivative of this, it would be 3/4 times x squared plus 5 to the 1/3 times the derivative of the inside. Oh wait, I forgot to bring down my 4/3, didn't I? 4/3. So that cancels, and the 2x matches what's up there. And so if you aren't sure if you're doing it right, you can kind of match it up here. Checking my time. Okay, so just jumping around to a few more here. What if they don't fit the pattern? So see, I think these two do fit. Do you need me, sir? It's all right. Just come on over. We're just going to have a lull in our recording for a second. You take each side to the third power. So add 1, divide by 4, then cube both sides because it's 1/3.
Okay.
So you do the third power. Okay. And I think I posted all my answers on Classroom for those two with my work. Okay. All right, so we did this one. It works out nice just like the other one. I'm not going to do that one for now, but you should do that one. But this one, again, if you think about this, if this was your function here, how would you get 2x plus 2? Oh, it looks like the ln one, right? And so, again, the ones on the previous page kind of help me see these, that this would be ln of x squared plus 2x plus c, because the derivative of ln would be u prime over u. And that's it. That works. But what if it doesn't work? Oh, I just made the noise. I hope that means it's still working. This one, the antiderivative of cosine is sine of 3x plus 2, but I'm missing my license to integrate, right? I'm missing that 3 that should be there. So what we have to do is figure out what we could put out here to make that balance. And so I can't just put a 3 in this problem, which is what I need, but what I can do is balance it out. So if I put a 3 in here, what could I put out here to keep it balanced? And I think the answer to that is a 1/3. And so if I just put a 1/3 in front of my answer, does that fix that missing license to integrate? And I think it does, because the derivative of sine would be cosine of 3x plus 2 times 3, but I have the 1/3 out here to balance that out. And so that's the part that we really have to work on, is what if it doesn't balance? What if it doesn't have that license? How do I fix it? Okay, so let's look at a few more here to see if I can finish up in like 12 or 13 minutes. What about this one? Looking again for like inside outside, I think it's helpful to like rewrite this. We have a 3x. We have x squared plus 2 to the 1/2. So I always look for that like inside function, and that would be this part. So what would I need for my license to integrate? I would need a 2x. But I have a 3x, right? So I have the x part. I don't need this 3. So one thing I could do is I could bring this 3 out front. And then I still have my x and my x squared plus 2 to the 1/2. But I need a 2, right? I'm not allowed to just put a 2 in a problem. There's no equal sign. But to balance that 2, I could put a 1/2 out front of my answer. And now I have my license to integrate to do my antiderivative. So I have 3/2 out here. And then if I do my antiderivative, if I add 1 to 1/2, that would be 3/2, right? And then I would need to divide by that, which would be times 2/3 plus c. So I think those even balance out. And so look what I get as my answer. I just have x squared plus 2 to the 3/2 plus c. Let's see if that gives me my answer here. The derivative of this would be 3/2 times x squared plus 2 to the 1/2 times the derivative of the inside, which is 2x. And look, the 2's cancel, and I get 3x times x squared plus 2 to the 1/2, which is that original problem. And so, especially at first, check your answers and kind of see what's happening here to make sure that you agree. But that's it. Those actually simplify out. And so you have to balance it out if you're missing that license to integrate. Okay? So let's look at this one. This one says the integral of 5e to the 3x. Just like up here, if you have a number in front that you don't need, like you can automatically move that out. We have a property that says that. This one, again, we're missing that license because what do I need here for that to balance? I need a 3, but I don't have a 3. So what do I have to put out here to keep it balanced? I would have to put a 1/3 because 1/3 times 3 is really just like 1. And so if I do that, then I just have a 5/3 out front. And what would be the antiderivative of e to the 3x times 3? It would just be e to the 3x. And again, check your answer if you're not sure. If you put a 3, the derivative of this would be e to the 3x times 3 times 5/3, and you would get that original problem. Okay, last one. This one, again, what do I see right away? I see the inside function as this. I'm going to rewrite it as 2x squared plus 3 to the 1/2. I'm actually going to bring it up and write it as a negative 1/2 in a minute. But think about what the derivative of the inside function would be. The derivative of the inside function would be 4x. So it's kind of like all the other ones. I have a 3x here, but I can separate the 3 and the x. So I'm going to do this. And I'm actually not even going to write this as a fraction anymore. I'm going to leave my x. And then I have 2x squared plus 3 to the negative 1/2. But that doesn't work. I'm missing the 4 that I need, right? That's my license to integrate. So I need a 4. So I can multiply by 4 if I also multiply by 1/4 at the same time. I just put the 1/4 outside the integral because I don't really need it to integrate. And now I have a 3/4 out here. So my x and my 4 are my license. And now I do my power rule. So I do 2x squared plus 3. Add 1 to that would be 1/2. Dividing by 1/2 is the same as multiplying by 2. So I get my final answer to be 3/2 times 2x squared plus 3 to the 1/2. And again, check my work here. If you take the derivative of that, you would get 3/4 times 2x squared plus 3 to the negative 1/2 times the derivative of the inside, which is 4x, and the 4's cancel. And so it really does work. Okay? And so if you look at the next set, it's just some more examples when things get a little crazier. And so that's what we'll pick up tomorrow.